this set of Snap Circuit videos, we're looking at projects PC42, the music meter PC, and going up to project 54, which is the Bird Sounds PC2. So, with project PC42, music meter PC, that's how it is in the book, and here it is on our board. So we're starting to make use of our sound meter along with our transformer here, and looking at it on the scope here using our circuits. So let me get Cam Studio going. And so we've set it up with half millisecond per division, and I brought the scale to a gain of 0.75. And we've got our slide switch all the way down to the lowest setting, and our meter is set to the low scale. So when we turn on our circuit, you can see the waveform on our scope here, but also you can see the meter deflection and maybe just see our red LED there flickering. Now I don't know how well the camera can pick it up or not, but the meter of course is a electromagnet, so we can actually hear the music IC's output through the meter there. It's just that it's very, very soft. And if we were to change our variable resistor settings, say we go all the way to the other end, now our waveform is looking more like a square wave because we're kind of topping out at the top and bottom based on the input of the computer here. And it's more audible coming from our meter there because more current's passing through it. Of course, you can see the deflection is maxing out on there, and our red LED is flickering nice and bright there again because there's more current going through the circuit with our variable resistor up at its highest setting. Of course, you can play around with the variable resistor to vary the amount of current going through the circuit, and of course change the way that the waveform looks in the process. So that's how project PC42 works. Well, before I stop, let's look at our FFT scale out of curiosity. That's low setting, here's the high setting. Okay, so now we see what it looks like at the two variations with the FFT scale. So, I'm going to move on to project PC43, which is the Oscillation Sounds PC now. So here we are at project PC43, the Oscillation Sounds PC. There it is in the book, and here it's on the board. So again, we're still using our transformer. We got a bit of an oscillator circuit using our two capacitors combined with our NPN transistor there. We're just going to switch on and off our transformer here, which is then going to give us an output on our speaker, and we'll see that on the computer with our waveform. So let me get Cam Studio going. And we're looking at a half millisecond per division, as usual, up to scale just a little bit. And with our circuit powered on, you can hear the constant tone being generated from the circuit coming out of our speaker, and also see one of the peaks of the waveform there on our half millisecond per division scale. Look at it in our regular one, you can kind of see what the waveform looks like there. Now with project PC44, we're going to start modifying the circuit. So with 44, we're going to put our whistle chip here across, let's see, C and B, which means we're going to put it across right here and see if the waveform changes. Now we can hear the output from the whistle chip there combined with it, and our waveform has changed a little bit. It's gotten a little bit longer in the wavelength, so a slight change in the wave. Not going to see too much difference on it though. So that's PC44. Take it off. And you see our slight change on the form go back. So with PC45, we're going to connect it across our C1 capacitor. Now you can hear that it's actually gone up in frequency when we put the capacitor there across C1. And we can see that reflected on our scope here, because now we have two peaks showing in the same frame, which means, again, higher frequency. The waveform itself is mostly the same, just that we have a lot more of it now. Again, accompanied by the higher frequency, or a higher oscillation rate of the circuit. So now what we're going to do for project PC46 is we're going to put the whistle chip over our C2 capacitor, but I need to actually take it out of the circuit first and place it on top, or top of the whistle chip, like so, and then put it on the circuit. And again, you can tell that it's a lower frequency now than what we started with, so there's more capacitance in the circuit. We still have our single peak there, and it's a little hard to judge on this without comparing it to the previous one, but again, it's an overall less oscillation, so therefore less frequency. So that's how Project PC46 works, and now we're going to move on to Project PC47, which is Oscillator Sounds PC. So here we are at Project PC47, the Oscillator Sounds PC. There it is in the book, and here it is on the board. So we've reconfigured the previous project a little bit by including our D1 diode here on the ground side, but we've also put our C2 capacitor and C1 capacitors in the opposite places, along with putting our R5 resistor in parallel with the C1 capacitor here on the base of our NPN transistor. So of course this is going to affect how the circuit oscillates compared to how it was configured with PC44. So let me get Cam Studio recording. We have our scope going on 0.5 millisecond per division, so I haven't changed any of the settings from the previous project. When we turn our circuit on, you can clearly hear that it's a higher frequency. Our LED is glowing nice and bright. We can see in our waveform here we've got about 3, sometimes 4 peaks popping up on there at this scale versus the previous project, which was at a lower frequency. And we can see that reflected on our other scale there. So now with Project PC48, what we'll do is we'll take our whistle chip and we're going to put that across our C1 capacitor. And when we do that, you notice that the wavelength changes so that now there's more spacing between each peak, and therefore of course we get a lower frequency, as you can hear on the speaker. And that's reflected in our other scale as well. You can see the spacing between each peak now. So that's how Project PC48 works, and now we're going to look at Project PC49, which is the Whistle Chip Sounds PC. So here we are, Project PC49, the Whistle Chip Sounds PC. There it is in the book, and here it is on our board. So again, we have another oscillation circuit outputting to our transformer, which then goes to our whistle chip with our couple capacitors and resistors, along with our NPN transistor helping drive it all. So let me turn on Cam Studio, get our scope recorded. And this time we're using our 5 milliseconds per division scale instead of the shorter one, so we turn our circuit on. Circuit charges up the capacitors, and then we get our little waveform there, and we can hear the tone coming out of our whistle chip, even though it's fairly quiet. So that's how the waveform looks with Project PC49. So with Project PC50, we're going to take our whistle chip and move it around the circuit so that we get this reconnected here. Then take this, and we're going to place this across our C2 capacitor. So we'll do it right here. And plug it in there. We get a slightly different interval. There's our waveform is very large on there now, so I need to bring the scale down some. After we look at it, it's looking like a square wave. Change it to our other scale. It's kind of interesting how it appears there. Now it says the circuit is supposed to be oscillating in short intervals, but from where it's placed here, according to this, it doesn't seem to be doing that. Although I think from the description of PC50 and 51, it looks like it's backwards. Yeah, they got some mix-up, I can tell, on this. So let me take the whistle chip, and now I'm going to put it directly across C1 here. Just put it angled like that, and it'll still work. Turn our circuit on. Oh, I think I know what's happening. Let's see. I think I know what might be happening. Yeah. Somehow, yeah, I'd noticed this in a previous project. It would appear that the cable they have with the snap circuit system has some kind of capacitance in it, because I've got it unplugged here and it's interfering with the circuit, not even plugged into the computer. I noticed this with the previous product, so it seems we have a rather faulty cable here, because as you know, the circuit should be doing this. If you can hear it from the whistle chip, it's oscillating at an interval, but the cable is adding capacitance to it or changing a characteristic of the circuit that I didn't expect. That might explain why we've had some strange behaviors in previous circuits. Well, let's move on to PC52. Now, I think they've got some text backwards in here, because again, this is supposed to oscillate in 2-second intervals. Let me add the capacitor here so we can get the circuit to do that. That hardly changed anything. Because you see, that's how the circuit behaves with the 470 microfarad capacitor added like they have it here. Interesting. Well, that's an interesting thing that I get to learn, and so do you watching the video, that it seems not only can there be interference and stuff, but it seems like the cable that came with the set here has its own problems. That's interesting. Anyway. Well, that's the whistle chip sounds for PC52. So PC53, we're going to add our speaker in place of the whistle chip here. Basically, the circuit stays the same, because when we use this, see, we should get a chirping sound out of our speaker. So let's see how that's going to behave with this connected. Let's see what it looks like on the scope, or if it behaves the same way. Okay, well, we get that working normally. So you can see on the scope there, of course, I'm hoping it shows up on the video when it gets uploaded later with the lower frame rate, that you can see the pauses or intervals on the scope there as we see the waveform and then briefly go away and come back again. Again, as the computer pulls that. Let's look at this on our half millisecond per division scale, and I'll turn up the scale too since it's a low output. So that's PC53. Now PC54, we're going to change out the 100 microfarad capacitor here for the 10. So let me get that out. So this should make the oscillation work in shorter intervals because there's less capacitance. While the opposite would be true if we use the 470 microfarad capacitor, then we get longer intervals. See, now the intervals are shorter between those pulses, and we can see that reflected a lot better on our scope for sure. Bring the trigger down a little bit. And so that's how Project PC54 works, and just for curiosity's sake, let's lengthen the intervals by putting a bigger capacitor on there, like our 470, just to make up for how the whistle chip project came out and get a little something extra here. So now the intervals should be longer because we have a much larger capacitor there to charge and discharge. Yeah, and you can see it and hear it there. So again, our frequency in this waveform stuff there looks pretty much the same, but you see the interval every time it pulses is a lot longer. So again, that concludes Project PC54 and this set of Snap Circuits videos.